So today we're going to look at word problems that have to do with volume. Before we focus on volume, let's take a little review. We've looked at problems that have to do with perimeter, area, and volume. And when you look at a word problem, you need to be able to determine what sort of problem is it. Is it perimeter, is it area, or is it volume? Perimeter problems are one dimension, area are two, and volume are three. When we measure perimeter, we use linear units like centimeters, meters, inches, feet. When talking about area, we always use square units like centimeters squared. And for volume, we use cubic units like centimeters cubed. So let's take a look at three problems. If a problem says Mrs. Kress wants to trim her bulletin board that measures 40 centimeters by 60 centimeters, how much trim does she need? You need to be able to think about, is this an area or a perimeter? When you talk about trim is to go around the outside, so this is a perimeter problem. Mr. Rich wants to put plastic wrap over the brownies he baked in a 9 by 13 inch pan. If he wants an extra inch on all sides, how much plastic wrap does he need? Well, he is going to go over the brownies in the pan. He's going to cover them, so that means that this is an area problem. Matthias wants to fill a wagon that is 2 feet wide, 3 feet long, and 0.75 feet high with blocks. How many 2-inch cubes will fit? We're looking at filling a wagon and how many will fit, so that's our clue that this is a volume problem. So you're going to have a little exercise today, and you're going to be determining when you read a problem, is it perimeter, is it area, or is it volume? You don't even have to calculate the answer, just determine what kind of problem it is. So you want to ask yourself, is this problem surrounding? Is it covering? Or is it filling, to help you determine if it's area or perimeter or volume? I had a teacher once that always said, when in doubt, draw it out. When a problem doesn't include a picture, it's helpful to sketch it. So let's take a look at an example. The librarian is putting books in a box that is 24 inches wide, 30 inches long, and 18 inches high. She only wants to fill the box halfway because she's afraid it'll be too heavy. What is the volume of books that she can place in the box? Well, they haven't given us a picture, but we could draw out a box that's 30 inches long, 24 inches wide, and 18 inches high. But she only wants to fill it halfway. And this is where drawing it out can help you to see what half of the box would be. Now, there's several different ways you could solve this problem. You could look at half of the height of the box would be 9 inches, half of the 18. So you could find the volume of the whole box, 30 times 24 times 18, and divide by 2. That would give you 6,480 cubic inches. Or you could use the half of the height that we found. That was 9. You could say 30 times 24 times 9, and you would also get 6,480 cubic inches. When you're looking at word problems, not just volume and area, but all word problems, you want to make sure that you know what the problem is asking. It may not be asking you for the volume. So with volume problems, sometimes they're asking you to find the weight or the cost. Sometimes they're asking you to compare volumes. How much bigger is one than the other? How much less is one than the other? And sometimes they're going to give you the volume and you have to work backwards to find a missing dimension. All these are considered volume word problems, even though the answer that they're asking for isn't the volume. Let's look at some example problems. Mulch costs $15 per cubic yard. If you fill a pickup truck that measures 3 yards long by 2.5 yards wide by 1 yard deep, how much will it cost for the mulch? Well, we're talking about filling a truck, so this is a volume problem, but are they asking for the volume? If you take a look at the problem, they're asking how much will it cost. And they also give you the key fact that mulch costs $15 per cubic yard. But we need to figure out the volume to figure out the cost. So the volume equals length times width times height. So that's 3 times 2.5 times 1, which gives us 7.5 cubic yards. So are we done?
No!
Now we have to find the cost. The cost is $15 for each cubic yard. So we take 15 times 7.5 and we get a cost of $112.50. Sorry, the slide cut that off. So let's look at another example problem. Water weighs 0.036 pounds per cubic inch. A small inflatable baby pool measures 40 inches long by 30 inches wide and 10 inches deep. The inflatable pool weighs 0.5 pounds. What is the total weight of the pool when filled with water? So again, we're talking about filling, so it is a volume problem, but are they asking us for the volume? They're asking us for the total weight, and they also tell us that water weighs 0.036 pounds per cubic inch. So to find the weight, we're going to have to first find the volume. So volume equals length times width times height. 40 times 30 times 10, which gives us 12,000 cubic inches. Are we done?
No.
Now we have to figure out the weight. So we have to take the 12,000 cubic inches times 0.036, and here's the part a lot of people will forget. We have to add the 0.5 because the pool weighs half a pound, and it said what is the total weight of the pool. When we multiply and add 0.5, we get a total weight, again it cut off a little bit, of 432.5 pounds. Hope that helps you to solve some volume problems.